F-117, a Nighthawk stealth fighter attack aircraft, was developed by Lockheed Martin. A Nighthawk stealth fighter attack aircraft was developed by Lockheed Martin after work on stealth technology, and the predecessor test demonstrator aircraft, Half Blue, was carried out in secret from 1975. Development of the F-117A began in 1978 and it was first flown in 1981, but it was not until 1988 that its existence was publicly announced. The Nighthawk was the world's first operational stealth aircraft. The first aircraft was delivered in 1982 and the last of the 59 Nighthawks procured by the U.S. Air Force was received in 1990. The F-117A aircraft is also known as the Frisbee and the Wobblin' Goblin. The mission of the aircraft is to penetrate dense threat environments and attack high-value targets with high accuracy. Nighthawk has been in operational service in Panama, during Operation Desert Storm, in Kosovo, in Afghanistan, and during Operation Iraqi Freedom. The Nighthawk is only used for nighttime missions. F-117A stealth fighter replacement and retirement. F-117 was to be replaced in the USAF by the F-22 Raptor before the F-22 program was cancelled in 2009 and replaced with the cheaper and more versatile F-35 Joint Strike Fighter. The first 10 of the 55 F-117 aircraft in service were retired in December 2006. A formal retirement ceremony took place at Wright-Patterson AFB in March 2008. The F-117s are being stored in hangars at an airfield in the Tonopah Test Range, Nevada. The wings and tails are being removed for storage, but some aircraft will be able to be rapidly recalled to flight if required.
The last 4 F-117 aircraft flew to Tonopah on April 22, 2008.
Nighthawk stealth fighter design. The surfaces and edge profiles are optimized to reflect hostile radar into narrow beam signals, directed away from the enemy radar detector. All the doors and opening panels on the aircraft have saw-toothed forward and trailing edges to reflect radar. The aircraft is mainly constructed of aluminum, with titanium for areas of the engine and exhaust systems. The outer surface of the aircraft is coated with a radar-absorbent material, RAM. The radar cross-section of the F-117 has been estimated at between 10 square centimeters and 100 square centimeters. The F-117A has 4 elevons on the inboard and outboard trailing edge of the wing. The V-shaped tail, which controls the yaw of the aircraft, acts as a flying tail, which means that the whole surface acts as a control surface. The elevons do not act as flaps to reduce the rate of descent for touchdown, so the landing speed of the F-117A is high, at about 180 miles per hour to 190 miles per hour, and a drag parachute is used. Cockpit. The cockpit has a Kaiser Electronics head-up display, HUD, and the flight deck is equipped with a large video monitor, which displays the infrared imagery from the aircraft's onboard sensors. The cockpit has a full-color moving map developed by the Harris Corporation. The fly-by-wire system is supplied by BAE Systems Aircraft Controls. Weapons. The aircraft can carry a range of tactical fighter ordnance in the weapons bay, including Blue 109B low-level laser-guided bomb, GBU-10 and GBU-27 laser-guided bomb units, Raytheon AGM-65 Maverick and Raytheon AGM-88 HARM air-to-surface missiles. In January 2004, an F-117 successfully released a JDAM 2,000 pounds bomb for the first time. The integration of JDAM and other precision-guided weapons on the F-117 is coupled with the Block 2 software upgrade and achieved initial operating capability, IOC, in 2006. FLIR and DLIR sensors. For stealth, the F-117A does not rely on radar for navigation or targeting. For navigation and weapon aiming, the aircraft is equipped with a forward-looking infrared, FLIR, and a downward-looking infrared, DLIR, with laser designator, supplied by Raytheon. The aircraft uses a Honeywell inertial navigation system. The aircraft has multi-channel pilot static tubes installed in the nose. Multiple ports along the length of the tubes provide differential pressure readings. The flight control computers compare these in order to provide the aircraft's flight data. Flight management. Before flight, mission data is downloaded onto the IBM AP102 mission control computer, which integrates it with the navigation and flight controls to provide a fully automated flight management system. After takeoff, the pilot can hand over flight control to the mission program until within visual range of the mission's first target. The pilot then resumes control of the aircraft for weapon delivery. The aircraft is equipped with an infrared acquisition and designation system, IRADS, which is integrated with the weapon delivery system. The pilot is presented with a view of the target on the head-up display, first from the FLIR and then from the DLIR. Weapon delivery and impact is recorded on the aircraft's internally mounted video system, which provides real-time damage assessment. F-117A engines. F-117A is powered by two low-bypass F404G F1D2 turbofan engines from General Electric. The rectangular air intakes on both sides of the fuselage are covered by gratings, which are coated with radar-absorbent material. The wide and flat structure of the engine exhaust area reduces the infrared and radar detectability of the aft section of the engine. The two large tail fins slant slightly outwards to provide an obstruction to the infrared and radar returns from the engine exhaust area,